Hello friends, today we are going to discuss about internal energy. Then we are going to discuss about distinguish between state function and path function. And lastly, first law of thermodynamics and its limitations. So let's start. Internal energy. Thermodynamic system containing some quantity of matter has in itself a definite quantity of energy called internal energy. This energy includes various types of energy components such as translational energy, rotational energy, vibrational energy, which together are taken as thermal energies. These three are collectively known as thermal energy. They come under thermal energy, translational, rotational, and vibrational. Then it has intermole and intramole energies, which are bonding energies, that is EB, electronic energy EE, and nuclear energy EN are also part of internal energy. The total of all possible kinds of energy is called internal energy. The total internal energy of a molecular system is given by E total is equal to Et plus Er plus Ev plus Eb plus Ee plus En. So Et is translational energy, Er is rotational energy, Ev is vibrational energy, Eb is bonding energy, Ee is electronic energy, and En is nuclear energy. The internal energy of a system is determined by the state of a system and is independent of the path followed by the system. Hence, internal energy is state function. Okay, so it is not a path function, it only depends upon the state of the system. The magnitude of internal energy depends on the mass of the matter contained in a system. Therefore, it is regarded as extensive property because it depends upon mass. The internal energy of the system is represented as E or U. Sign conventions. If E1 is equal to internal energy of the system in initial state, that is reaction, E2 is equal to internal energy of the system in final state, that is product. Exothermic reaction. If E1 is greater than E2, means if initial internal energy is greater than final internal energy, then what happens? Internal energy of reactant is greater than that of product, then delta E is equal to E2 minus E1 is negative. In such case, energy will be given out to the surrounding. Therefore, energy of system decreases. Hence, reaction will be exothermic. Means heat is released, heat is given out of the system. Next is endothermic reaction. If E2 is greater than E1, then internal energy of the product is greater than that of reactants. Delta E is equal to E2 minus E1 is positive. In this case, the energy will be absorbed by the system from its surrounding. Therefore, energy of the system will increase and hence reaction will be endothermic. The SI unit of internal energy of a system is joule. Uh, it is J. Symbol of joule is J. So that much you have to write if a question of internal energy came in your exam for 5 marks. Now next is distinguish between state function and path function. Okay, this is related to FY BSc chemistry student. Distinguish between state function and path function. State function depends only on the current state of the system, not on how it got there. Path function depends on the specific path or process taken between two states. State function is independent of route taken. Path function is dependent on the route or method used. State function, it is represented by exact differentials du, dh, ds. Path function represented by inexact differentials, example delta q, delta w. State function, it is a point on pressure volume diagram, whereas for path function it is area under the curve on pressure volume diagram. Examples of state function and path function. State functions are internal energy, pressure, temperature, volume, enthalpy, and entropy. Path functions are heat and work done. So that's the difference between state and path function. 5 points each. Now next is first law of thermodynamics. The total energy of an isolated system remains constant, though it may change from one form to another. So that's the general statement of first law of thermodynamics. The first law of thermodynamics was stated for the first time by Mayer and Helmholtz in Germany, and later by Joule in England and Koldin in Denmark in 1840. The following are some of the selected statements of the law. So let's see some important and selected statement for first law of thermodynamics. Energy can neither be created nor destroyed, but can be converted from one form to another. The energy of isolated system remains constant. Whenever one kind of energy is produced, an exactly equivalent amount of another kind of energy must disappear. Energy of the universe is constant. It is impossible to construct a perpetual machine. It is impossible to construct a perpetual motion machine which could produce work without consuming energy. So these are the few important statements of first law of thermodynamics. So isolated systems energy always remains constant. Then one kind of energy is produced, then another kind of energy gets disappear. Okay, energy of universe is always constant, and it is impossible to construct a machine which can produce work without consuming energy. That's not possible till now only. Okay, then next, energy and mass are connected by the relation E is equal to mc square, where c is the velocity of light. Hence total mass and energy of the isolated system remains unchanged. Now let's see the mathematical expression for first law of thermodynamics. For the formulation of first law of thermodynamics, the concept of internal energy is used. Let E1 be the energy of a system in its initial state. When the system absorbs an amount of heat Q, the internal energy is given by E1 plus Q. If W is the work done on the system, the internal energy E2 in the final state of the system will be given by E2 is equal to E1 plus Q plus W. So let's take E1 on that side. E2 minus E1 is equal to Q plus W, or delta E is equal to Q plus W, or we can shift that Q is equal to delta E minus W. So basically we take delta E is equal to Q plus W. That's the first law of thermodynamics mathematical expression. It is the expression for first law of thermodynamics if, however, work is done by the system. Okay, if work is done on the system, then work done is positive, but if work is done by the system, then work is taken as negative. So delta E is equal to Q plus W becomes delta E is equal to Q minus W, because in this case work done is by the system. Okay, earlier it was work done on the system, that's why it is delta E is equal to Q plus W, and here work is done by the system, so delta E is equal to Q minus W. And after mathematical expression, last part is limitations of first law of thermodynamics. So this law fails to tell us that the source of heat and direction of flow of heat. Okay, so it does not tell us about the source and direction of flow of heat. Then second, it does not define the ease or extent of convertibility of one form of energy into another. How much amount of energy gets converted from one form to another. So it does not talk about that. Third one, so long the total energy is conserved whenever any change takes place, the first law is satisfied. but it does not ensure for a process to occur actually. From the point of view of this law, difference between spontaneous and non-spontaneous process is of no significance. Okay, because the first law does not explain about spontaneous and non-spontaneous process. Generally, spontaneous is the process which takes place on its own, and for non-spontaneous process we have to apply external heat or pressure. That process is non-spontaneous. Fifth one, it fails to explain why natural, that is spontaneous processes are unidirectional. Then sixth one, this law cannot explain why all naturally occurring processes always tend to change spontaneously in the direction which leads to equilibrium. It does not say whether heat change is exothermic or endothermic. Work can be completely transformed into heat, but heat cannot be completely converted into work without causing permanent change in the system or surrounding. This observation could not be explained by this law. And last limitation, according to this law, it is impossible to have 100% efficiency for heat energies, for heat engines, or for that matter, self-acting machines. However, experience tells that such engines are not possible in practice. Okay, so there is not 100% efficiency of conversion of heat into work. There is no such machine exists till now. Okay, so engines are not possible in practice. So that was the last limitations of first law of thermodynamics. Total 9 are there. Thanks for watching the video.